Yo, what's up, everybody? This is Mr. Nixon. Wanted to do a quick video to kind of review over the bones. I managed to snag a color skull and a few individual bones. And this is going to be just a general review. It's going to be literally me going over each one of the bones of the axial skeleton, talking about a few of the details, a few key concepts about it. And so let's go. So if you notice this green bone here in the front, this would be our frontal bone. This bone, of course, is the bone that makes the forehead. You will notice that there's a thickened ridge along here that is above the orbits or eye sockets. The thickened ridge is what's known as the supraorbital margin. Supra meaning superior, orbital talking about the orbits, margin because of the thickened ridge here. And that's what our eyebrows sit on. Then underneath, you'll notice that there is a little snagged area here. It's a little notched out area. That notched out area, of course, is what's known as the supraorbital notch. That supraorbital notch typically has an artery that runs along the ceiling of your orbit. And then that artery runs through the notch and then provides blood for the muscle and skin of the forehead. So that is the supraorbital notch. Here in the front, you will see the nasal bones. We had these written in our list, but sometimes we don't get a chance to actually take a really good look at them. The white and the gold on both sides. They colored them differently so that you could see that you don't have a nasal bone, but instead you have nasal bones. You can see how small they are. You can see how flat they are, which is why it's so easy to break someone's nose, because you're breaking these little small bones. If you continue on here, making up the face, you have a maxillary. You got the right maxillary bone. You've got the left maxillary bone. You put the two bones together, you make the maxillae. Here is an individual maxillary bone. This is your right maxillary bone. You see it from the side, see it from the front. And here's a rare internal view of the maxillary bone. So this is the maxillary bone here. And also on the maxillary bone, we talked about one of the specific details. We talked about that little hole. That is the infraorbital foramen. Infra being inferior, orbital talking about the orbit or the eye socket, foramen because a foramen is a hole or a canal in a bone that important things pass through. So in this case, we actually have a nerve that passes through that hole, and that nerve actually innervates muscles in the face, allows you to feel things on your face as well as control muscles for facial expression and talking. Now, I'm going to do something a little odd. I'm going to take this skull and I'm going to flip him like this so that you can see an inferior view. And if we see the inferior side of the maxillary bones, we also see these two little gray things. These two gray bones here are your palatine bones. Your palatine bones are shaped like L's. As a matter of fact, I think I got one right here. This is the palatine bone. Notice that it's shaped, well, if you look at it from the side, it's shaped really weird. But if you look at it from the back, this is actually a posterior view that you're looking at it with. This is shaped like an L. And so when you get two of these and you put them together, you take one L, you take another L, and you stick it together like this, and then it inserts into the roof of your mouth, which is what you're seeing here with this gray. If you show it at this angle, you can see some of the gray going straight down. And so it's like an upside down L right now, and it attaches in the back of the roof of your mouth. So you put those two L's together and it makes the palatine bones. They make the posterior roof of your mouth. So we flip this back around. Now we're looking at an anterior view of the face. We've got the zygomatic bone here. think I got a zygomatic bone. Yes, I do. This is a left zygomatic bone. So let's go to this side. Let's try to do this without dropping the skull. Here is your zygomatic bone, an individual. He's the sky blue thing that you see on the color skull, but there's an individual zygomatic bone here that I'm holding up to the camera. Now, this individual zygomatic bone, it has processes, and a process is an extension off of a bone that attaches to something important. So, you'll see a process attach a bone to another bone. You'll see a process attach a bone to a tendon, which attaches to a muscle. You'll see a process attached to an important ligament that attaches to another bone. You see something very significant attaching a process to another process, or a process to another bone. So this is the zygomatic bone. You can see this little small piece of the zygomatic bone attaching it to the maxillary bone here. That's why this would be known as the maxillary process. And then you see this piece of the zygomatic bone attaching it to the frontal bone. That makes this the frontal process. And then you see a little piece of this blue attaching to the temporal bone, which makes this portion of the zygomatic bone the temporal process. And then keeping with that, you see this purple bone. This is a sphenoid bone. Not a sphenoid bone, I'm sorry, a temporal bone. And this temporal bone attaches to the zygomatic bone. Now, this is where it gets kind of tricky. So I'm going to try to make this very clear. The zygomatic bone and the temporal bone have adjacent articulating processes. So they attach to one another with a process. These processes are named for the bone that they are attaching to. So this zygomatic bone has a temporal process because this process is attaching to the temporal bone. This temporal bone has a zygomatic process because its process is attaching to the zygomatic bone. When you take the zygomatic process and the temporal process and put them together, it creates something called the zygomatic arch. And the zygomatic arch is the temporal process plus the zygomatic process. Put together, they make the zygomatic arch. Some other things that you'll find on the temporal bone, you see this little spine right here sticking out the bottom. That is the styloid process. You have muscles that attach there that help you chew and swallow. You have the mastoid process here, which is the knot behind your ear. And then you have this hole, which is actually a canal. It's the external auditory canal, sometimes referred to as the external auditory meatus. This is the canal or meatus. They're both, meatus means canal, but this is the canal that passes straight through your ear. It's the ear canal that you sometimes stick a Q-tip in. That is the same hole. Moving right along, you've got this yellow bone here. There's actually two yellow bones, this one and this one. These are parietal bones. They make the roof of your skull. And then you get to the back of the skull, which is the occipital bone. There's a knot in the back of your skull, and that knot happens to be the external occipital protuberance. External because it's outside of the skull, occipital because of the bone, protuberance because it's a protrusion on the surface of the bone. Now, you have to call this external occipital protuberance because you actually have an internal one on the inside of your head. There was a freak accident one time where a girl who had just graduated from Clemson was rollerblading in Clemson, and she was going down some steps. She flipped backwards and slammed the back of her head into one of the marble steps that she was going down, and she wound up dying from internal bleeding. They called out forensic scientists and everything to make sure it wasn't foul play, and it turned out it wasn't. When she landed, she wasn't wearing a helmet. She landed directly on her external occipital protuberance, which pushed the internal occipital protuberance into the back of her brain, and it knocked her unconscious, and she died that way. So freak accident type stuff, the Final Destination kind of level stuff. So That is the external occipital protuberance. If you continue to rotate the skull so that you can see the base or the bottom, there's a large hole here in the base of the skull. That large hole is the Foramen Magnum. Once again, a foramen is a hole that something important passes through. Magnum means very large. So this is a very large hole, and your spinal cord passes through there. On both sides of the Foramen Magnum are these little rounded protrusions. You can take your finger and you can feel the shape of it. It's smooth, it's rounded, and it kind of protrudes out from the bone. Those are occipital condyles. So those are occipital condyles. Condyles are rounded protrusions that stick off of a bone. They almost always attach to something very important. In this case, a lot of times they also have some type of movement, some type of roll in body movement. In this case, it allows your head to nod like this. Another very important bone is a very bright yellow bone that you can see here. That bright yellow bone is actually the sphenoid bone. If I take the roof of the skull off like this, all of this that you see here, that's the sphenoid bone. And if you're having trouble kind of conceptualizing that, here is a disarticulated bone. So here is a disarticulated sphenoid, and then there is the bright yellow to my left is the sphenoid bone inside of the skull. And if you try to learn this, you probably want to get a whole skull and then get a disarticulated skull and then hold the bones up beside it so you can start to see the patterns, because there are patterns to this thing. When you look in here, there's the sala turcica, which is that space nicknamed as Turkish saddle. And if you look at the saddle on a camel, you can kind of see where they get it from. It's that little space right there in the center. And then you have this area here, which makes the lesser wings. And then you have the area on this side and the other side, which make the greater wings. So these are lesser wings. These are greater wings. And if you are looking for the optic canals, if you look there, there's a hole here and a hole on that side. It's a lot easier to find if you look at it from a posterior view. Find the sala turcica, find the lesser wings, and then look for two small little holes that pass in between them, and you'll find the optic canals. And optic canals allow your optic nerves to pass through. This dark red that you see here is actually the top of your ethmoid bone. This is an ethmoid bone. That's the anterior view of the ethmoid bone. This is a lateral view of the ethmoid bone. This is an inferior view of the ethmoid bone. Several people, when they see this view in the book, it throws them for a loop. They don't know what they're looking at. But this is an inferior view of the ethmoid bone. Don't get this confused with a superior view. This is not. This is an inferior view. When you're looking at the top of the ethmoid bone, it should look like that. And the reason why is because the top of your ethmoid bone has the crista galli, this little shark fin looking thing. And so you have a crista galli there, and then this space right behind the crista galli, that surface there, that's the cribriform plate. So you have the cribriform plate, there's a crista galli, and then when you look at it from an inferior view, the perpendicular plate, if you look at this very closely, you're going to see this small line that's running straight down the middle. Do you see that? My pinky is kind of pointing to it. You see that piece of bone that looks like a line is running straight up and down? That is the perpendicular plate. On this model, the perpendicular plate is extremely short. You can see it from an anterior view too. There's the perpendicular plate running straight up and down here in the very middle. The perpendicular plate is very short on this model. In a real person, it would be a lot longer because it's got to come down and attach to the cartilage, the septal cartilage in your nose and the vomer to make your nasal septum. Some last bones, just in case you weren't able to find these. If you look very closely in the eye socket, you'll see a dark green bone. That dark green bone is your lacrimal bone. Your tear ducts actually sit in that bone. That's why they call it lacrimal bone, because your lacrimal glands actually sit in the lacrimal bone. So that dark green is your lacrimal bone. Also, if you look inside of the nose, you'll be able to see some faint orange in there. That faint orange is referring to this bone. This is a vomer. And so the vomer bone is looks like a little dagger or something. Looks like someone threw a shuriken in it. This was a piece that broke off. This is the part that goes into your nose and goes straight back. And it's on the floor of your nose. It's actually right here. This thing is actually your vomer. It's on the floor of your nose, and it helps to create your nasal septum, which is that wall that divides the left from the right. And that would be your, got it upside down. There we go. That would be your vomer, like this. All right. Cool. So that's a very, very quick explanation of the skull. Now we're going to go into the next segment, which is we'll spend a few minutes on vertebrae and some other weird things. So remember, for your vertebrae, that you have 24 vertebrae, you have 7 cervical vertebrae, you've got 12 thoracic vertebrae, and you've got 5 lumbar vertebrae. Remember the breakfast, lunch, dinner method. You have an early breakfast at 7, you got lunch at 12, and a really early dinner at 5. Breakfast, lunch, dinner, 7, 12, 5. 7 plus 12 plus 5 gives you 24. So there's 24 vertebrae. There are 3 different categories of vertebrae. There are cervical vertebrae, which pretty much look like this. You have thoracic vertebrae, which look like this. And then you have lumbar vertebrae that look like this. Now, although you have 3 categories of vertebrae, their names are very easy because you've got 7 cervical vertebrae, so they're named based on the first letter of what category of vertebrae they are, and then which number in which order, number or order they're in. So, boy, that sounded weird. So you got 7 cervical vertebrae, so they're known as C1 through C7. You have 12 thoracic vertebrae, so they're known as T1 through T12. And then you have 5 lumbar vertebrae. They're known as L1 through L5. So that's how that works. Some people will look at the vertebrae and they'll say, oh my gosh, they look exactly alike. I can't tell them apart. And some people are like that. Some people don't readily pick up on key distinct differentiations. So you need to take time and look at it and ask yourself what is different, and then verbally try to explain to somebody what is different. If you just stare at them and they're just going to look the same, and you're going to be calling this a lumbar or something like that, or you may even make your own name up. You might call this crayon. So you look at it and you say, well, there's got to be something distinct about it that makes it unique. So you start asking yourself very basic, very, very basic questions. Like, how many holes does a cervical vertebrae have? 3. How many holes does a thoracic vertebrae have? 1. Whoa. Check that out. All of your cervical vertebrae have 3 holes. Your thoracic and your lumbar vertebrae only have one. So thoracic and lumbar, one hole. Cervical, three holes. When you look at your cervical vertebrae, and it's important to look at your vertebrae in a vertebral column with all 24 articulated with one another, you'll notice that most of your cervical vertebrae have this general shape, whereas thoracic vertebrae, they typically have this general shape. They kind of got this whole giraffe looking thing going on with the sloped spinous process here. And then lumbar vertebrae, they obviously don't look like anybody else. Lumbar vertebrae are definitely the largest vertebrae, look like the head of a moose or some type of Jurassic Park monster or something like that. So some different parts of the vertebrae that really stand out. Spinous process is the one that sticks out of your spine. It's the one that if you palpate someone's back, you can feel it in their back. You can feel that little thing, that little piece sticking out of the middle of the back. That's the spinous process. These little processes on the side, these are transverse processes. The hole in the middle is the vertebral foramen. That hole is supposed to be there. That hole is for your spinal cord to pass through. And believe it or not, your spinal cord doesn't take up all that space. It's actually a very small structure. So when we get to spinal cord, we'll talk more about that. This is the body of the vertebrae. And then your vertebrae, they tend to stack on top of one another. So they have these little places where they articulate with one another. So if I had another vertebrae, I could stack that lumbar on top of this one. This is an L5. So this is the last lumbar in your back. So if I had an L4 with me, I could stack that L4 and you would see it literally slide into place. And it would have these faucets. Its inferior faucets would articulate with the superior faucets of this particular lumbar. And they would attach to one another. And when you bend your back, they kind of slide a little bit so that you can have some type of flexibility. Same thing on the cervical vertebrae. That's the spinous process. These are the transverse processes, but they have three holes. So these two holes here are transverse foramen. You'll learn later on that the transverse foramen allow blood vessels to pass through, to go arteries to pass through, to go up to your brain, and then veins to pass through to come down from your brain. When you look at it from this perspective, you can see the superior articulating faucets and the inferior articulating faucets are underneath here. After your vertebrae come your sacrum and your coccyx. I wasn't able to get a coccyx, that's your tailbone, but this is a model of the sacrum. Your coccyx would have extended here. And it would have been about anywhere from 3 to 5 segments attached here. Your sacrum and your coccyx are pretty interesting. Your sacrum is known as your butt bone. You look at it from this perspective, you can see 1, 2, 3, 4, 5. These were 5 segments. When you were inside your mom, these 5 segments were separate. But over time, they begin to fuse together to become one bone. The same thing with your coccyx. Your coccyx was anywhere between 3 and 5 bones. Over time, they fused together and they became one bone. The purpose of these bones is to protect the contents of the pelvic cavity. These holes have numerous nerves that pass through them. So that's why it hurts so bad when you land on your rear end, because it's just all these nerves, there's bundles of nerves passing through these holes. So when you land on something like concrete, yeah, you're basically taking your nerves and smashing them with this bone hammer against the concrete. That's not going to feel very comfortable. So that's what happens with that. But this is the sacrum. Sorry, I don't have a coccyx, but the coccyx would actually extend out from this point here. The last thing that you guys had to go over was actually the ribs and the sternum. I did manage to grab one of these guys. So this is your breastbone, This is your sternum. Your sternum is actually made up of three parts. There's the manubrium, the body, and the xiphoid process. So your sternum's actually made of three parts: manubrium, body, xiphoid process. The manubrium is named as such because the Romans felt that it looked like a manubrium, which a manubrium is the hilt of a short sword. If you watch Gladiator, the movie, or any of those movies that come on Netflix that are during Roman times, and you look at their swords, they had short swords. And these short swords, the hilt where the blade and the handle connected was known as a manubrium, and it's shaped just like one. This, of course, is the body of the sternum, which is the majority of the sternum. And then this is the xiphoid process. Now, remember what we said. Process is an extension off of a bone that has important things that attach to it. So, of course, this thing has important ligaments or important tendons and muscles that attach to the xiphoid process. And we'll talk about those muscles later on. This little part right here, that's an actual joint. And most people, that thing is fused together. It's solid. But in some people, like myself, it's not completely fused. The joint is actually movable. And so, just like people crack their knuckles, I can crack and pop this joint. I know it's kind of gross, but hey, it is what it is. These plastic or rubber looking things, these are representing cartilage, because the ribs of your body don't actually come all the way around to attach to your sternum. Your ribs actually attach via cartilage to your sternum. So you have three classes of ribs. You have true ribs, false ribs, floating ribs. True ribs are ribs that attach in your back, and they go all the way around, and they attach by individual cartilage to your sternum. Then you have false ribs. False ribs attach to your back. They come around to the front, but then you'll notice here that they attach with cartilage, but all of that cartilage fuses into one, and then that one piece attaches to the sternum. Then you have floating ribs, which they attach to the back, but they don't even attach to the front. They come around like this, and they just kind of sit there on your side. They literally float. So your true ribs are ribs pairs 1 through 7. They all attach to the sternum individually. 1, 2, 3, 4, 5, 6, 7. So they each have their own individual piece of cartilage that allows them to attach to the sternum. Your false ribs, ribs 8, 9, and 10, they don't have their own piece. They have to share a piece. So 8, 9, and 10, 8, 9, and 10, they merge and form one piece of cartilage that attaches to the sternum. And then your floating ribs is just pairs 11 and 12. They don't attach to anything. That's why they call them floating. They just attach to the side and they sit there. They just protect your kidneys. So that is everything. That's the axial skeleton. Looking forward to doing one on the appendicular skeleton, and hope to work with you guys soon. Holla at you later. Wakanda forever.